We are starting Unit 2 today. Unit 2 is all about inverses and composition of functions. And so our first several lessons, this is not a very long unit. Our first several lessons will be about inverses. So today we'll talk a little bit about inverses in general and how we find inverses graphically and how we find inverses algebraically using the equation. Okay, so here it goes. Okay, so we're looking at Lesson 2.1, inverse functions. It says make a table of the values for the function g of x, reverse the ordered pairs in the table for g of x, and graph the resulting relation. So I put down the points, my 4 points that are dotted here on g of x. I'm going to reverse those now, so my y values become my x values become my y values, -6, -2. And then I'm going to plot these. I'll probably speed up the video while I plot these because it'll be kind of boring watching me do this. So 6, -7, -6, -2, 3, 3, -9, +8. All right, so there's what we have, kind of this Z-looking thing here. The relation that reverses the domain and range of a function is called the inverse of the function. So the first question here is the inverse of g of x a function? I can pretty clearly see that this red function that I have graphed here does not pass the vertical line test, so the answer is no. And if anybody asks me why to justify that, I would say does not pass the vertical line test. Okay? Moving on. All right, so my points here, -9, they have these written down. -9, -6, -2, -4, 2, 5, 8, 7. So I'm going to reverse those. 6, -9, -4, -2, 5, 2, 7, 8. 9, and we speed this up, graph this. -6, -9, -4, -2, 5, 2, 7, 8. Okay. Is the inverse of f of x a function here? And the answer is yes, it is. So what characteristics of functions does f of x have that g of x does not? So what separates f of x, the graph on the front here, from the graph over here? And the fact is that f of x is 1-to-1. G of x is not. F of x is 1-to-1. So in order to have an inverse that is a function, the function must be 1-to-1. Notation for the inverse function is f to the -1. It's like a little power here, f to the -1x. We can say inverse f of x. So x, if we put the function f on x is our input into the function f, our output is f of x. If I take that f of x and inverse it, use the inverse function on it, then my output is x. So in other words, f inverse of f of x is equal to x. All right, a couple points about this. Inverse function, if f of x is a 1-to-1 function, its inverse is also going to be a function. F of x and f inverse x are symmetrical about the line y equals x, and you can see that's why on these graphs that this y equals x is drawn in, so you can see how it's symmetrical that way. Same thing over here, this y equals x is drawn in, so you can see how it's symmetrical around that. Third bullet point, the domain of f is the range of inverse f. The range of f is the domain of inverse f. Last, and this will become more important later, f of f inverse of x equals x, and f inverse of f of x is equal to x as well. So if I have an equation and I want to find the inverse, this is what I do. I replace f of x with y, so I'll have y equals something with x in it. We switch all the x's and y's. All the y's become x's, all the x's become y's, and then we solve for y. And that resulting function will be your inverse function. So, it says for the following functions, sketch f of x and f inverse on the same grid. State the domain in the range of both f of x and f inverse of x. Find the equation for f inverse algebraically. Alright, so let's start by, I'm going to make myself a little table here over to the side. I know that the smallest number I can put here is -3. If I put in -3 for x, I'm going to have 0. If I put in -2, I'm going to have the square root of 1, which is 1. If I put in a positive 1, plus 3 is 4, I get 2. And if I put in 6 plus 3 is 9, square root of 9 is 3. Alright, my domain, so this looks like, well, let's go on and graph this. -3, -2, 1, 1, 2, 6, 3. And the graph looks something like this. Alright, the domain, -3 to infinity, including -3. The range, from 0 to infinity, including the 0. So I know for the inverse that those will be reversed. My domain down here will be 0 to infinity. My range will be from -3 to infinity. So algebraically, we're going to find the inverse. So first step is write f of x as y, so y equals the square root of x plus 3. I'm going to switch the x and y, so x equals the square root of y plus 3. Now I'm going to solve for y. So to get y by itself, my first step, I want to get rid of the square root sign here, so I'm going to square both sides. So x squared equals y plus 3, the square root and the square just cancel. And then I subtract 3, and I have x squared minus 3 is equal to y, so that's my inverse. X squared minus 3. Now what's interesting about this, and I'm going to graph this using the red pen, what's interesting about this is that I have a limited domain. This is not your normal x squared minus 3 that's going to go from negative infinity to positive infinity. Instead I'm going to start at 0. So if I make a table for this, we'll start at 0. If I put in 0, I get -3. If I put in 1, I get -2. If I put in 2 squared minus 3 is 1. If I put in 3, 9 minus 3 is 6. And you can see that's exactly the opposite, the reverse of these points up here. So 0, -3, 1, -2, 2, 1, 3, 6. And graph that. So I'm only getting half the parabola here because of my restricted domain. We'll talk more about restricted domains in the second lesson of this unit. All right, let's go to the last example. Okay, f of x equals 2x plus 7 over x plus 3. I know that the denominator cannot equal 0. That means x cannot equal -3. So my domain is from negative infinity to -3. Everything except for -3. Okay? It is everything except for -3. Now we'll talk more about this when we get to talking about rational functions. But basically, if I look at these first two terms, 2x over x in my fraction here, 2x over x, that's going to tell me, if I just do 2x divided by x, it would be equal to 2. And so that's the asymptote, that's the value that the range, the y value, will never equal. It will never equal 2 no matter what. So it's going to be everything except for 2 here. And we'll see that more clearly when we do the inverse, and we'll see that the domain down here will be everything except for 2. All right, so -3, I'm going to draw an vertical asymptote at -3. I'm going to have a horizontal asymptote at +2. And then I'm not going to worry about being super specific here, but let's just get a couple points. If I put in 0 for x, I'm going to get 7/3. 7/3 would be 2 1/3. Okay? 7/3 is 2 1/3, so it's about right here. All right, so I know that it's going to follow the asymptote going up, and then it's going to follow the asymptote here going to the right. Okay? And then the other thing, if I'm getting an x-intercept, it's basically going to put the numerator here equal to 0. If I say 2x plus 7 equals 0, 2x equals negative 7, x equals negative 7 halves, that's negative 3 1/2. So on the x-axis, if I go to negative 3 1/2, which is right here, I know that that's a point on the graph. And so it's going to look something like that. So that's not super specific, but it's good enough. We have the brackets, the hyperbole branches in the right basic area. All right, so let's find the inverse now. And we're going to be doing this several times, so watch the process. The process doesn't really change. When we have a rational that we're looking for the inverse of, first step is switch your x's and y's. X equals 2y plus 7 over y plus 3. All right, I want to get rid of, the first step to get the y by itself is let's get rid of this fraction. So we'll multiply both sides times y plus 3. On the right, it simply cancels out. It's always the first step, get rid of your fractions. On the left, I'm going to distribute the x. So I have xy plus 3x. Now, notice I've got two terms with y and two terms without y. So I want the terms with y on the same side of the equal sign. So I'm going to subtract 2y from both sides. So xy, I'm going to put that minus 2y next, plus 3x equals 7. And then I'm going to move anything without a y to the right. Minus 3x on both sides here. This is a positive 7. So that's going to cancel. Up here, this canceled. So xy minus 2y equals negative 3x plus 7. All right, last step. Well, not quite the last step, but we're getting there. I'm going to factor, I have a common factor now of y. I'm going to factor that y out. Equals negative 3x plus 7. And now I'm going to divide both sides by x minus 2. X minus 2's will cancel. And my inverse is negative 3x plus 7 over x minus 2. And I can see, so let me write that down. Negative 3x plus 7 over x minus 2. I can see pretty clearly that x cannot equal 2 from my denominator here. If I put in 2 for x, I get 0 in the denominator, and that's a big no-no. So negative infinity to 2, 2 to infinity, exactly the same as the range I had up here. The numerator will give me the zeros where it crosses the x-axis. So if I said negative 3x plus 7 equals 0, then negative 3x equals negative 7, x equals negative 7 over negative 3, or the negatives cancel, 7/3. Okay? So, oh, yeah, that's not exactly what I was trying to find here. I'm sorry, yeah. Yes, okay, this is right. We'll use this in a minute when we're graphing it. Sorry about that. To get my other asymptote, I look at these first terms here, negative 3x over x. My x's cancel, I get negative 3, so it's going to be everything except for negative 3, just to get exactly like the domain was above. All right, so let me graph with the red on the inverse here. So we're going to go everything except for 2. So notice that what was a horizontal asymptote on my original graph is now a vertical asymptote. I had 2 up here, 2 above, here. Now it's vertical 2. And it's negative 3 down here, whereas it was negative 3 on the vertical asymptote on the original graph. I just found my x-intercept is 2 1/3 right here. And I need one more point. So if I put in 0 for x, going up to my equation here, if I put in 0 for x, I'm going to get 7 over negative 2, negative 3.5. So if I come down here to negative 3.5, I'm going to have a point here. And so I can see that this is going to follow those asymptotes, and it's going to head this way. And then on this side, it's going to come through that negative 3.5 and then turn. And it'll look something like that. Okay? All right, that's it.